first part of today we're going to look at identifying linear functions, and we're going to either be looking at a graph or we're going to be looking at a table. So first of all, we need to know the definition of a linear function. We know that a function has no repeat x values, and so that's part of our definition. But a linear function is just a function that forms a straight line. So if we look at a, b, and c here, we can identify which ones are linear functions. So a happens to be a straight line. It's also a function because it passes the vertical line test. So a is a linear function. So we can say a is. B happens to be a function, but it doesn't form a straight line. So this is no, it is not a linear function. And then C happens to be linear, but it is not a function. Remember, because the vertical line has an infinite amount of points that are on top of each other. So this is linear, but not a function. Or, yeah, not a function. Okay? So that's how we can look at a graph and determine that. All right, so straight lines, for the most part, will be linear functions, except for vertical lines. That's about it. If there's any curves or bends to your line, that's not going to be linear, but it could still be a function. All right. Secondly, you can look at a table and determine, before you even graph it, if it's going to be linear. So if we look at this particular table on the left, we have a table that goes, if we look at the x values, -2, -1, 0, 1, and 2. So you can see, as they show on the left side here, there's an increase of 1 each time. And then if we look at the y values, they go down by 3 each time. So 7 minus 3 is 4. 4 minus 3 is 1. 1 minus 3 is -2. -2 minus 3 is -5. If there's ever a consistency where there's a constant change in x and there's a constant change in y, has to happen at the same time, then we can say that this will be a linear function. You could graph this and prove it to yourself that this will be linear. Okay, we'll talk about that in class a little bit more. So that's a linear function. If I look at this one, however, we can see that yes, it does increase by 1 each time on the left side between my x values. However, there's an inconsistency in the y's. It doesn't go up or down by the same amount each time. It goes down 3, then it goes down 1, then it goes up 1, and then it goes up 3. So this is not, it could be a function. Oh wait, let's make sure it is. Okay, at least these points will be, because there are no repeat x values. So it is a function, but it won't be linear. So not linear, even though it is a function. All right. So those are some things that we can look at with a table. So we can look at points, or a set of points here too. So right away, you should be able to tell if it's going to be a function or not. But to tell if it's going to be linear, let's take our x values and our y values and put them into a table. So 2, 5, 8, 11. And 4, 3, 2, 1. Pretty easy to tell that the y values are going to go down consistently by -1. So that's good. And let's see, x, or 2 to 5, that's going to be +3. 5 to 8, +3. 8 to 11, +3. So we're good on the x side. We're also good on the y side. This will be a linear function because there are consistencies in what it increases or decreases by on both sides. Let's take a look at the second piece, and this will be the last example for this video. So x and y, got -10, -5, 0, and 5. So it is a function, but will it be linear? 10, 4, 2, 0. We can see that on the x side, it's going to go up by 5 each time. So that's good and consistent. So -10 to -5 plus 5, excuse me. And if I check out the right side now between my y's, looks like we go down 6, then we go down 2, and then we go down 2 again. So there's an inconsistency here. We go down 6 and then down 2. So this is a function, but it's not going to be a linear function. So not linear. So not a linear function. All right. The second video today we'll talk about standard form and being able to look at an equation and determine if we have a linear function or not.